All right, so last time we gave ourselves a nice little overview of what variables are, how to name them, about being consistent, and all this other good stuff. Now we're going to switch gears and talk about specific data types. This first time around, we're going to talk about numeric types, and I don't feel like these need that much explanation, but there are some underlying technical things that we need to be aware of. So, with any data type, there is a function that we can call to directly create that variable. You can always create a variable of a type by just giving it a value of that type. However, sometimes it may not be entirely clear, and we have to cast a variable to a given type. So it's going to be very common that you'll cast an integer to a string, which we'll talk about in the next lecture, in order to be able to print it. So let's start with integers. If we think back to our middle school math classes, we know that these are whole numbers. So 10, 20, 80, 500,000, any of these, also negative whole numbers, and 0. These are all integers. These are all supported by the integer data type. Python 2, which we do not use in this class, had integer variables with different sizes. You had your regular integers that were 32 bits long and longs that were 64 bits long. We're using Python 3, which does not place a strict limit on integer length. So you can make your integers as big or as small as you want them to be. So any fractional parts, if you try to take an int and give it a value of 3.5, that's just going to give you a 3. So let's click over here to Visual Studio Code, and let's make a comment. It's showing some examples of how to create an integer. So let's say age, that's one we used before, 30. This is one way you can do it. You can also say velocity. That's another. Let's give that a value of 120. Let's say speed limit is 70. And let's also show how you can do this with the int function. Let's say your velocity is 120.3. And now we want to cast it to an int. So we do int. And in Visual Studio Code, if you select something and type an opening parenthesis, it'll put the closing one at the end of the selection. So we have that. And the other thing you can do is you can assign integers to a mathematical expression. So let's say exceeded limit by equals velocity minus speed limit. And so these are ways that you can create variables of the integer type. And just for fun, let's print exceed limit by. And now we need to save this. So let's find our save button, save as. And we're going to save it inside of here. We're going to save this as data types.py. Now let's go into our working directory. open in terminal, and let's run this. You see, that gives us 50 instead of 50.3 because the value for velocity was truncated from 120.3 to just 120. And truncating is when we take data and we just lop off a bit of it. So these are ways that we create integers. Now we're going to create floating point numbers. And we just typically call these floats. So a float is what we're used to calling a decimal number. So think pi, or the Euler constant, or the acceleration of Earth's gravity, 9.8 meters per second. Anything that involves a decimal point is a floating point number. You might also call these real numbers, because yes, we can have an integer in a floating point number. It's just going to include a 0.0 at the end. Now, all floating point numbers are double precision. This means that the depth of precision for your fractional part is quite high. It's not going to represent every single possible real number. Sometimes you'll see cutoff, and this can do some odd things. But in general, these are 64-bit long pieces of data. They are limited, but the limit is this monstrosity of a number that you see here. These two, both negative and positive. And any more than 1 point is considered infinity. Anything less than negative all of that is considered minus infinity. So now, let's make some floating point numbers. So we could just say pi equals 3.14159. That is as far into pi as I know. We could also say radius equals float 16, and that's going to give us 16.0. And now let's do another that uses a mathematical calculation. So we have pi and radius. Let's just do circumference, which is going to be pi d, or 2 pi r. So pi times diameter, or pi times double the radius. So that would be, I might have misspelled it, I don't know, but circumference equals 2 times, remember that times in typed math is going to be an asterisk. We'll get to talking about operators later on. So you have 2 times pi times radius. And now we'll print circumference. We save what we got. Remember, that's done by pressing Control S. And let's run our code. And so our circumference is 100.53, yada, yada, yada. All right. So that's how we do our floating point numbers. The last one we're going to talk about for this lecture in any detail is going to be complex numbers. Now, complex numbers, we got to think to our pre-cal, our algebra 2, our more advanced math. And this is, we also think of these as imaginary numbers. So if you remember, imaginary numbers result from taking the square root of a negative number. That is something that our number system cannot do. And so we have imaginary numbers as the as the workaround. My high school math teacher always referred to them as glitches. So when we create a complex number using its function, that function is complex with the real value first, a comma, and then the imaginary value after that. And again, this contains a complex number that is of the type, or is of the format, it could be 2j, it could be 3 plus 8j, it could be 2.2 minus 3.6j, that sort of a plus, or x plus yj format. Now, you might be thinking, hold on a minute, why is it j? Should the imaginary part be I? When we talk about loops, we'll see why, but needless to say, I is already in use as a naming convention for something else. So let's click back over to our code. We're going to make some complex numbers. And we'll say, I don't really have an idea for how this would work, so I'm just going to call it a weird number. And you can do it this way. You can do 2 plus 6j, and it'll, no, Scarlett. 2 comma 6j, or we can write it explicitly. It could say another weird number. Let's face it, complex numbers are one of the screwiest things in mathematics. We can just say 6.5 minus 13j. We can do it both of those ways. And now let's print both of these. Click save, and we'll run it one more time. And there you can see our imaginary, or our complex numbers. So those are our numeric types. Similar to these, we also have binary types. That's your byte array, and memory view. We're not ever going to have any use for these, but just be aware that they do exist. They do have their purposes, but because they're a little advanced in what they're used for, we're not going to talk about it here. So next time we're going to talk about non-numeric data types. That's going to be strings, booleans, and the none type. So stick around for that.